Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to go over a few examples of how to use conversion factors to solve problems. So let's get into this. So first thing I want to do is pick out anything that is a conversion factor. Anytime that you have a relationship between two different things, two different units, that's going to be used as a conversion factor, or it's possible it could be used as a conversion factor. And then once you figured out what the conversion factors they give you, then the next thing you want to do is find the question, and then in the question, 99% of the time, they're going to tell you where to end and where to begin. So the beginning of the question is the end of the problem. And then throughout the rest of the question, whatever else they give you, most likely you're going to find the starting position there. Okay, so let's get into this. So number one, this is just a question, so we want to pull out any conversion factors. There's no relationships. It says, what is the capacity in millimeters of a gallbladder that can hold 1.54 fluid ounces? Okay, so there's no relationships. There's nothing being related to anything else. So we don't have any given conversion factors. So we need to figure out where we're going to begin and where we're going to end. And so the beginning of the question is the end of the problem. So what is the beginning of the question? What is the capacity in millimeters of a gallbladder? Okay, so we want millimeters of the capacity. We want the capacity of the gallbladder in millimeters. So we need to get to a certain number of millimeters. Well, where are we going to start with? What are we going to start with? Well, we read the rest of the question, we find our answer. We want the capacity in millimeters of a gallbladder that can hold 1.54 fluid ounces. So they're giving us 1.5 fluid ounces. We want to convert that to milliliters. So we always begin with given start. So there's 1.54 fluid ounces. We're going to put that over 1, and then we're going to just start converting. And you could use whatever conversion factors that you know, as long as whatever's on top is canceling out with whatever's on the bottom here, and then you get your new unit on top. So we're going to add conversion factors until we get the unit milliliters on top. So if we start with fluid ounces, well, if we know fluid ounces, we can relate that to quarts. So 1 quart is equal to 32 fluid ounces. So we could put 32 fluid ounces on top. Let me make sure I got that right. Yep. And 1 quart on the top. So fluid ounces will cancel out. And now we have quarts. We can convert quarts to gallons. So we know one gallon is equal to 4 quarts. So in this case, we'll put 4 quarts on the bottom, 1 gallon on top. So quarts cancels out. Now we have gallons. So what we can do is convert gallons to something like liters, right? So we know that 3.785 gallons is in, or liters is in 1 gallon. Let me just double check that really quick. 3.785 liters. So we're going to put 1 gallon on the bottom and 3.785 liters on top. So gallons cancels out. And now we can use the metric conversion factor. 1 liter is equal to 1,000 milliliters, or 1 milliliter is equal to 1/1000th of a liter. Either one works. I'm going to use the 1 milliliter. So on the bottom, I'm going to put 10 to the negative 3, or 1/1000th of a liter is equal to 1 milliliter. Liters cancels out. I have milliliters. Milliliters is what I want, so I'm done. So now all I need to do is multiply across the top, divide by what's on the bottom, and I get my answer. And when I do that, I get 45.5. 45.5 milliliters. And so we got to think about sig figs. So your answer, the rule is when you multiply and divide, your answer should have the same number of sig figs as the measurement with the least number of sig figs, ignoring exact measurements. So 1 quart to 32 fluid ounces, that's exact. 1 gallon to 4 quarts, that's exact. 1 milliliter to 1/1000th of a liter, that's exact. 1 gallon to 3.75 liters, that's a measurement. And then, of course, we were given this measurement. So here we have 3 sig figs. Here we have 4. The least number is 3. So therefore, our answer should have 3 sig figs. So that's why it's 45.5 milliliters. Okay, that's number 1. Number 2, we're given the density of water at 3.98 degrees Celsius is 1.00000 grams per milliliter. What is the mass in pounds of 17.966 liters of water? So, first thing we want to do is pull out the information, find conversion factors. Remember, conversion factors is where you have one unit related to another unit, something per something. So if we look here, we have density, which is relating to units, mass unit, volume unit, grams, milliliters. So we can use this as a conversion factor to convert between mass and volume. That's going to be important. Why? Because they're asking us a question where we're going to convert to mass. But they're giving us liters, which is a volume unit. So in order to get from the volume to the mass, we need to use the density as a conversion factor. Okay, so remember, we pull out the information, we find conversion factors they give us that we could use. The next thing we need to figure out is where we're going to start, where we're going to end. And we go to the question. The beginning of the question is the end of our problem. What is the mass in pounds? So we need to find the amount of pounds. So we're going to have to get to pounds. But what are we going to start with? The only other information they give us is 17.966 liters. Notice that this measurement that they're giving us is not related to anything. It just stands alone. So that is a good indication that that's what we're going to start with. And so we're going to start with 17.966 liters of H2O over 1. And now we start converting. We want to get to what? We want to get to mass in pounds. So we need to convert liters to a mass unit. We have this relationship, grams to milliliters. If we add milliliters, we could then use that to convert to grams. So our first step should be to convert this to milliliters. So 1 milliliter is equal to 1/1000th of a liter, or 1 liter is equal to 1,000 milliliters. Either one's fine. I like milliliters. So 10 to the negative third liters, or 1/1000th of a liter, is equal to 1 milliliter. So liters is on the bottom to cancel out with liters here. So we got water. So liters of water cancel out. Now I have milliliters of water. Now I can use my density as a conversion factor. So here, so I have milliliters on the top here. I'm going to put milliliters on the bottom. So 1 milliliter of water. And then on the top is the 1.5 0.00000 grams of water. Milliliters of water cancel out. Now I have grams of water. Now I want to get to pounds. So I can use a conversion factor. So 453.6 grams. Let me double check that. Yes. 453.6. So 453.6 grams of water is equal to 1 pound of water. So grams are going to cancel out. And all I need to do now, I have pounds. So that's what they're looking for. We want pounds. So we stop here. Now all I need to do is multiply everything on the top, divide by everything on the bottom, and I get my answer. And when I do that, I get 39,608. So 39.608 pounds of water. So let's double check our sig figs. So remember again, when you're multiplying and dividing, the rule is that your answer should have the same number of sig figs as the least number of sig figs in your measurements, and ignoring the exact measurements. So 1 milliliter to 1/1000th of a liter, that's exact. This milliliters to grams, that is not exact. That's a measurement. We have we have this here, grams to pounds. That's not exact. That's a measure. That's a inexact measurement. And so let's count the number of sig figs. So here we have 1, 2, 3, 4, 5, 6 sig figs. Here we have 4. And then here we have 17.966. So that has 5. And so here we have 5, but the least number is 4. So we're going to round this to 0.61. And so that would be the answer in the proper number of sig figs. Okay, next we have, what volume of blood in quarts is pumped through your muscles in 143 minutes of work that causes your heart to pump 24.2 liters per minute, 79.25% by volume of which goes to your muscles. So that's a mouthful. Let's go ahead and break this down. Let's pull out the information that we need. So conversion factors, we want to pull out information that has units related to each other that we could use to help us convert from one unit to the other. So here we have this 143 minutes of work. That stands alone by itself, right? So we'll come back to that. There's no relationship here that causes your heart to pump 24.2 liters per minute. So this is going to be a conversion factor because it's relating volume and time, minutes and liters. We're given a percentage by volume. This is important. This is a conversion factor. Anytime you're given a percentage, you can write that or understand that as a conversion factor, because if you understand what a percent is, that tells us that it's out of 100. Percent means out of 100 per 100. So if this is 79.25% by volume, they're telling us the amount of volume of blood that goes to your muscles out of 100 units that go to your heart. So all of the blood is getting pumped through your heart. Well, 79.25% of that blood, it goes to the muscles. So what does that mean? So for every, so let's say liters, it doesn't matter what unit we use, we can just say unit. So for every 100 units of blood that's pumped through your heart, 79.25 of those units gets pumped to your muscle. So we could use whatever unit we want. So out of 100 liters of blood that gets pumped to your heart, 79.25 liters gets pumped through your muscles. You could use gallons, right? Out of 100 gallons of blood that's pumped to your heart, 79.25 gallons is pumped through your muscles. So that's how you can use the relationship. So that's a conversion factor. So now that we have our conversion factors, we're going to underline that. So what do we do with this 143? So we need to figure out what to begin with and what to end with. So the beginning of your problem, the end of your problem is the beginning of the question. What's the beginning of the question? What volume of blood in quarts is pumped through your muscles? So we want to know the quarts of blood that are pumped through your muscles. Well, what are we going to begin with? They give us 143 minutes. So if you read the rest of the question, we find this 143 minutes that stands by itself. So we're going to start with 143 minutes, and we're going to use our conversion factors to convert to quarts of blood pumped through the muscles. So we're going to start with 143 minutes. And we want to convert minutes to something else. Right away, we can use our conversion factor of minutes related to liters. So let's go ahead and do that. So 1 minute is equal to 24.2 liters. So we're going to put 1 minute on the bottom, 24.2 liters on top. So minutes cancels out. So we have liters now. Now we have a couple of things we could do. We could convert liters to quarts right away and then use the percentage to convert from quarts of blood through the heart to quarts of blood to the muscles. One thing I should mention here, I should write, you want to specify what you're talking about. Liters of what? It's liters of blood to the heart. So the heart is pumping 24.2 liters per minute. So I put BH for blood to the heart. Why do we want to specify blood to the heart? Well, because we're going to convert that to blood through the muscles, and we don't want to confuse our units. So we can either convert liters to quarts right away and then use the percentage, or we could use the percentage in liters and then convert to quarts. It doesn't matter how you do it. Let's see. I will do it. I'll use the percentage first. So I know that 79.25% of all the blood that gets pumped through your heart goes to the muscles. So since I have liters out of 100, since percent means out of 100, I know out of 100 liters that of blood that gets to the heart, 79.25% of that blood, or 79.25 liters out of 100 goes to the muscles. So I have liters of blood to the heart on the top. So I'm going to put 100 liters of blood to the heart on the bottom and 79.25 liters of blood to the muscles. I'll say BM for blood to the muscles. So then liters of blood to the heart gets canceled out. And now I have liters of blood to the muscles on top. So now I can convert liters to quarts, or I'm sorry, liters to, quarts. And so I can use the same conversions up here, right? So I can use liters to gallons, and then I can convert gallons to quarts, right? Or if you know a direct relationship between liters and quarts, you could use that. So let's see if I have, nope. So I'm going to use gallons to liters. So I'm just going to use this conversion here to convert liters to gallons. So here, so I know 1 gallon is equal to 3.785 liters. I'm going to put 3.785 liters of blood to the muscles on the bottom and 1 gallon of blood to the muscles on top. So liters of blood to the muscles cancels out. I mean, liters of blood to the muscles cancel out. Now I have gallons of blood to the muscles. Now I can use 1 gallon is equal to 4 quarts to convert to quarts. So 1 gallon of blood to the muscles on the bottom and 4 quarts of blood to the muscles on top. So gallons of blood to the muscles cancels out. Now I have quarts. Now I'm done. Quarts is what I want. So now all I need to do is multiply across the top, divide by the bottom to get my answer. And when I do that, I get 2.90. 2.90 times 10 to the third, and let me double check that, third quarts. And so that is the answer in quarts. So when we're talking about sig figs again, when we're multiplying and dividing, the answer should have the same number of sig figs as the least number of sig figs in the measurements we are dividing and multiplying by, minus ignoring the exact. So we have 143 here. That's a measurement. This is not exact. Minutes, time, and volume. That's not going to be exact. This is not exact. This is given to us, this percentage. This is not exact. Gallons to liters. Gallons to quarts is exact, so we can ignore that. So here we have 3 sig figs. Here we have 3 sig figs. Here we have 4. Here we have 4. And we're going to ignore that. So the least number of sig figs is 3. So I have 2.90. So 2.90, that's 3 sig figs. So this is the correct answer. So now for number 4. So this is our last problem. So we have the moon orbits the earth with a velocity of 2.3 times 10 to the third miles per hour. What is the velocity in meters per second? So here it's a little bit of a different problem. Here they're giving us a velocity in miles per hour. They want us to convert meters. They want us to convert that velocity to meters per second. So they're not giving us any conversion factors. This is a standalone rate or velocity. So we're going to start with that, and we're going to multiply. We're going to multiply and divide to get our meters, and to get our seconds from miles an hour. So let's go ahead and do that. So we're going to start with 2.3 times 10 to the third miles on top. And then 1 hour is going to be on the bottom. So we're going to write it like this as a fraction because that's what it means. It means 2.3 times 10 to the third miles per 1 hour. And so what we're going to do is we're going to use conversion factors to convert the hours on the bottom to seconds, and we're going to convert miles on top to meters. So again, different ways that you could do this. So you could convert miles to feet, and then feet to inches, and then inches to centimeters, and so on. Or you can convert miles to kilometers, and then kilometers to meters, right? Whichever makes sense, whichever one you know or is the shortest. We're going to convert using kilometers. So I'm going to convert miles to kilometers. So for that, it's going to be 1.609 kilometers. So 1 mile is on the bottom. Since I have miles on here, I want miles to cancel out. So I'm going to put miles on the bottom to cancel out miles. And I'm going to put 1.609 kilometers on top. So miles cancels out. And now I can convert miles to kilometers to meters. So I'm going to go ahead and do that. So then kilometers goes on the bottom. So I know that 1 kilometer, sorry about that. So 1 kilometer is going to go on the bottom, and kilo is 1,000. So 1 kilometer is 1,000 meters. So kilometers cancels out. Now I have meters on top, which is what they want. So I'm done with the top now. Now I need to convert the bottom. So since I have hours on the bottom, I need to put hours on top for my next conversion factor. So here, so I know that 1 hour is equal to 60 minutes. You may know that 1 hour is equal to 3,600 seconds. So you could use one conversion, but most people don't know that. So I do know, most people know, if not everyone knows, that 1 hour is equal to 60 minutes. So I'm going to put 1 hour on top, and then 60 minutes on the bottom. This is 60 minutes. So hours cancels out. Minutes is now on the bottom. Now I can convert minutes to seconds. So for my last conversion factor, so since I have minutes on the top, I'm going to put minutes on the, since I have minutes on the bottom, I'm going to put minutes on top. So I have 1 minute on the top, and then I'm going to have 60 seconds on the bottom, since 1 minute is equal to 60 seconds. So minutes cancels out. I have seconds on the bottom, which is what they want here. So I am done with the conversion factors. So hours, or say minutes cancel out. So I have seconds on the bottom, meters on top. So now all I need to do is multiply by everything on the top, divide by everything on the bottom, and I get my answer. And when I do that, I get 1.0 times 10 to the third. Let me double check my answer. Yes, meters per second. This is my final answer. So notice the sig figs. Again, when you're multiplying and dividing, the answer that you get, the rule is that your answer should have the same number of sig figs as the least number of sig figs in your measurements that you're multiplying and dividing, ignoring the exact relationships. So here I have 2 sig figs in my answer. The great thing about scientific notation is that whatever digits you have over here, that's the number of sig figs. So we have 2 digits, that's 2 sig figs. This is 4 sig figs. This is exact, so we're going to ignore that. Hours to minutes is exact. Minutes to seconds is exact. So the least number is 2 sig figs. And so my answer has 2 sig figs. And that, ladies and gentlemen, is how you use conversion factors to help you convert and solve problems. I hope this was enjoyable. I hope you enjoyed the video. I hope you learned from this video. If this was helpful in any way, then please like the video, share the video, hit that like button over there somewhere. Also, make sure that you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or a question you need help with, or if you have a topic you would like me to cover, put that down below. I would love to do that for you. Thanks for joining me and have a great day.